Countersink holes can be created using a standard drill path or a chamfer drill path, depending on the desired flexibility of the process, as well as the length and detail of the output of the G-code. I'll demonstrate a countersink operation on the solid holes to the back of the part. These holes already have a 1/4-inch hole drilled through them, but I need to add the countersink. First, I'll drag my insert arrow to the bottom of the Toolpaths Manager. Then I'll use right-click Copy and paste to copy operation 2 under countersink. I'll click on Parameters to set up this toolpath. In Cut Parameters, I'll make sure I'm set to drill. Then I'll go to Tool, select a 1/2-inch 82-degree countersink tool, and renumber it to 11. I'll go to Hole Segments, where I'll select only the countersink for this operation, then switch to the linking parameters. For top of stock, I'll click the Select a Point icon, then select the arc on the top surface that represents the diameter of the countersink. To set the depth, I need to have Mastercam calculate the distance the tool needs to go into the part to match the diameter of the countersink. First, I'll set the depth to the top of the countersink by clicking the Select a Point icon, then selecting the top of the countersink. Then once I'm back in the Linking Parameters page, I need to click the checkbox for Calculate Depth from top of line/hole. This changes the way the calculation works on the back end, essentially simplifying the linking to calculate directly from the top. Finally, we need to click on the Calculator button in the Depth field to open the Depth Calculator. This allows us to adjust the depth by a specific value to get the tip of the tool to leave a countersink of a specific diameter. The calculator pulls in our tool information, so defining your tool correctly in the library is important for this type of operation. Assuming the tool is defined correctly, we can right-click in the Finish Diameter field and select the option for D+ diameter of an arc. I'm sent back to the graphics window where I can select the top diameter of the countersink. Once selected, I am sent back to the calculator, which updates with the values necessary. Since we already set the depth field before using this tool, we can set the bottom option to Add to Depth and green check. My linking parameters update. And after I green check, we can double check in Backplot that the tool is going to depth correctly by looking for striations between the tool model and the part model. I'll green check out of the parameters, then switch to a right view so I can more easily see the countersinking movement. I'll backplot only the countersinking toolpath, where I can see the tool enter the hole and cut down to create the Create Countersink shape. Now, I'll run the G-code. Here I have both G99 and G81, which indicates I am turning on a drilling cycle, and the code is short yet concise. I can also create countersink holes with a chamfer drill, and since I already have one created, I'll go ahead and run the G-code. I have the same G90 and G54 references, as well as a Z position. However, in this code, I have a G1 Z position and feed rate, which isn't strictly drilling, like I saw in my previous operation. Also, the code output for chamfer drill is longer, which may impact which type of toolpath you use for creating countersink holes. Whether using the standard drill path or the chamfer drill path, understanding the nuances of G-code output and toolpath parameters is crucial for precision in machining countersink holes.